As I told you, see that if you take the water in any kind of measuring cylinder, like a buretta or whatever it is, you see, when the water has been filled in the beaker or this measuring cylinder, the upper layer of the water, if you notice it, next time you go and see that, it will be see that the water is rising towards the container at the top, and they used to form a curved surface. Okay, so this is what we used to call it as a meniscus. Okay, now in the same thing, if you do not have mercury, but if you are having a mercury, and if you try to fill in this measuring glass or measuring tube, the mercury will be rising like this. So you'll form like this upper meniscus. This is upper meniscus, and this is what meniscus we used to say is lower meniscus. Understanding? And if I have been taken a pure water, okay, I'm actually a chemical engineer, so I used to deal with even mercury, even half kg mercury I used to deal. So that much I have been done. So if you're taking the pure water, see that water level will be, it will never form lower meniscus or upper meniscus. It will be exactly to the level. Clear what I'm saying, Pradosh? If I take the dirty water or normal water, or if I take methyl iodide, some substances, they will form the lower meniscus. If I take the mercury-like substances, they will form the upper meniscus. So what is this concept? That is only we used to call it as a contact angle and shape of the meniscus. So this is also because of surface tension and the inner energy and outer energy. So that is what we are going to discuss now. So if I have been taken, there is a liquids, like you can notice it. So this meniscus we used to call it as a concave meniscus, and this meniscus we used to call it as a what? All of you? Convex meniscus. We'll discuss that. Okay. So now if I have been taken, all of you observe, everybody. So there is a liquid which I am having it. So there is a liquid, example, you take it as a dirty water or you take it as a methyl iodide. So I'm having a methyl iodide, okay, or I'm having a impure water. Now if I bring some jar, measuring jar, and if I inserted measuring jar, I'm not talking about inside, see that measuring jar, I notice it, the liquid is started rising towards to it. Do you understand, everybody? So rising towards to it. Now, that is what, let me take it is a glass jar. Okay. So now, same way I have taken another kind of a liquid. Okay. So here I try to insert the same glass jar. So now if I notice it here the liquid is trying to contact the glass jar, glass tube, but here they are started pulling downwards. That is what it is, like this. You can notice it. Do you understand, everyone? I have drawn inside the beaker, inside the measuring jar, but this is outside. Be careful, that is. Okay. So now here I have taken example. This is what we used to call it as a mercury. Let me take it. So now by seeing itself, we can say it is forming concave or convex, everybody. So it will form the meniscus. That is what? Formed a meniscus. A liquid will form meniscus. So what meniscus it is, everybody? It is a concave meniscus. Concave meniscus it is forming. Now here it is forming. What meniscus it is? Anybody? Convex meniscus. Understand, all of you? Yes, brothers? Rudreshwar? So it is a concave meniscus, and it is a what meniscus? Convex meniscus is forming. So example I have taken, this is methyl iodide and this is mercury. So please observe, everybody. So one is methyl iodide, another one is I have taken what? Mercury. So now if I observe very carefully, all of you observe here. Somebody is missing, yaar. Pradeep Verega, Kadari. Okay. So if you all observe here, so this is mercury, it is forming downwards and it is forming upwards. Now I will say one statement, write it, everybody. So what is the concept we are studying now here? Contact angle. All of you keep reading. Contact angle. Contact angle which will represent with the theta. That is what? You have to draw tangent. Tangent to liquid surface. Tangent to liquid surface. But it has to be drawn outside. Tangent has to be drawn outside. Next, tangent to solid surface. Tangent to solid surface, but it has to be drawn towards. Okay, clear everybody? Pradosh? So tangent to liquid surface outside, tangent to solid surface towards to it. So that is what. So if I draw both, then the angle between them is we used to call it as a what? All of you? Contact angle. So first one, if I take it here, so this is what is a contacting point, whatever it is. Now, first one, we have to draw tangent to a liquid surface away from the liquid. Next, tangent to a solid towards to it. Towards to it, if I draw, then what is the angle between them? The angle between them is actually theta. That is the theta which we used to call it as. What is the theta we used to say, everybody? Contact angle. Understand all of you? So now, in this case, if you notice it here, by seeing here itself, we can say is that theta will be actually less than 90 degrees. The theta will be what? How much, everybody? Less than 90 degrees. If it is less than 90, it will form concave. Less than 90, if then it is concave, so that the liquid will rise. Liquid will rise. So please remember that. Liquid will rise. Understand all of you? Yes, please respond, guys. Yes. So here, here, if you have noticed, all of it, yes. So next here, if you notice again, so it is a convex. So convex again, we have to draw tangent towards to the liquid. Sorry, tangent away from the liquid and tangent towards to the solid surface. So if I draw, so what is the angle between? Anybody? Less than 90, more than 90, or what is that? Anybody? See that it is tangent away from it and tangent towards to it. So what is the angle? Everybody? Greater than 90 or less than 90? Theta is greater than 90. So then the meniscus which will form is actually the convex. So if I take, for example, mercury, you know that the angle it will form 137 degrees. If I take methyl orange, the angle will be just 29 degrees. That is what? See that it is a concave meniscus 29 degrees. It is a convex meniscus 137 degrees. That is what example mercury I am taking. So in these cases, liquid will rise. Now in these cases, it is going downwards. Downwards means physics word, we will use it one thing. What is that word? Anybody can tell? If it is forming a downwards path, we used to call it as a, yes please, depression. So liquid will depress. Here liquid will rise. Here liquid will depress. That is what it will be happening. So if theta is less than 90, liquid will rise. Theta is greater than 90, liquid will depress. So based upon what, sir? Which liquid will rise, which liquid will depress? That is we are discussing now. See, if I consider the pure water, for example, if I consider the pure water, I already told you. So what will happen, everybody? So there is no rise and there is no kind of inverts or like liquid rise or liquid depress. So liquid will be having what, everybody? Liquid will be having, yes please, the same parallel position. So if I draw tangent towards to the away from the liquid, tangent away from the liquid and tangent towards to the liquid, towards to the solid, what is the angle between them, everybody? What is the angle between them, all of you? 90 degrees. That is what? If the theta is equals to 90, then there is no upper meniscus, no lower meniscus. It will never rises, it will never go depress. So it will be parallel. So that is what we used to call, like example, If I take pure water, it is what will happen. Okay, everyone? All of you understanding? So now, what makes these liquids to rise up or go depress? Again, the concept call it as a why it is happening. The rising or depressed. The reason behind is the types of forces. So that is the forces which we used to call it as a cohesive force and as well as adhesive force. Do you all understand, all of you? One is cohesive force, another one is what force? Everybody? Adhesive force, another one is what force? Cohesive force. Okay. So cohesive force means the force of attraction present between same kind of molecules. That is what we used to call it as a cohesive force. Adhesive force means the force of attraction between different kind of molecules. The force of attraction between different kind of molecules. That is what we used to call it as a adhesive forces. Now, the liquid is coming and contacting with the solid here, the glass. Now, can you tell me which is adhesive and which is cohesive? Anybody? The particles and particles, liquid contact, adhesive forces. Liquid solid for contact, what forces we used to say? Everybody. Liquid solid forces, what forces we used to say? All of you. Yes, please. Innara, the liquid is contacting with the solid. That is adhesive force. The liquid is contacting with the liquid. It is cohesive force. Do you all understand, everybody? Please respond. Everyone? Yes. All of you? Cohesive forces means, suppose if I take water and water, the force between the water particle and water particle, that is what cohesive forces. The force between water and the glass, that is what we used to call it as a what force? Everybody, adhesive forces. Understand, all of you? So, based upon this force, it will decide either it is rising up or coming down. So if I take, for example, generally if I drop, there is a glass surface. All of you take it. Now, if I take this glass surface, everybody, I have dropped the water. Try to drop the water. You see, the water will form a curved surface. It is not complete spherical. It will form, try to minimize its surface area. So that is what due to surface tension. So it will be water drop. So the surface tension is equals to 0.75 Newton per meter. Even yesterday I have taught it. But if I drop the mercury, you see, mercury will be completely turned up into spherical in shape. So here it is not turned up into spherical. It is just trying to form a curved path, closed path. Now here if you notice it, the mercury. So mercury drop, if I make it, it will be completely turned up into what? Everybody. It will be completely turned up into spherical in shape because its surface tension is 0.465 Newton per meter. So now tell me, surface tension of water drop is greater or surface tension of mercury is greater? Anybody? Surface tension of water is greater or surface tension of mercury is greater? Everyone? Yes, I am asking you only. Surface tension of water is greater or surface tension of mercury is greater? Are 0.015, 0.465. Theriyada on the difference? You are not understanding the difference. What is this? Yes, guys. Which is having greater? Which is bigger? You don't know. 0.075 and 0.465. Which is greater? This much poor means what I can do? Mercury. So that is what. So remember, the surface tension is greater, then they will be completely turned up into the spherical in shape. Okay, everybody. So now if I have taken here, so there is a, if I consider this water, for example, the force between water and water, adhesive or cohesive, same particles, adhesive or cohesive? Cohesive. So is actually less than force between the water and glass. So this is water and glass. What we used to call? Which we used to call it as adhesive. So that is the reason you see, if I take the water, impure water, if I take the impure water, so if I place the glass tube, so what will happen? The impure water. So water will be rising up or down, rises up or depression it will make. They'll started rising. Yes, please. Rising up. Understanding, Amma? So that is what. So we all knows that liquid, we have to draw tangent away from it. That is what water and water pressure. And if you take the surface, so what will happen, all of you? So liquid surface is always, remember, perpendicular to the net force. Liquid surface is always perpendicular to the net force. So the force between the water and the glass, it is acting perpendicular. So water and glass. So if they both are acting, then we all knows that net resultant force act what? Net resultant force will act between them. So this net resultant force, that is what? The liquid surface, if you have been taken, so the liquid surface is always perpendicular to net force. That is what you have to remember. Okay. So actually the angle, both are 90 degrees angle between them. So if I take the mercury is forming completely spherical in shape because the surface tension of mercury is greater than surface tension of water. So you might be understand now, if the surface tension increases, the spherical shape will form more better and beautiful. Okay. So more stronger, more completely spherical in shape it will form. So now if you take here, so what will happen? The force of attraction between mercury to mercury is less or more? Anybody? Is more than actually surface tension. That is what force between mercury and glass. So that is what. So here cohesive force is more. Why? Surface tension is greater. So cohesive forces is greater than the adhesive forces. Cohesive forces is great. Here cohesive forces are less than the adhesive forces. Here cohesive forces are greater than the adhesive forces. That is what the liquid will pull down. So if I take the water in the beaker, all of you remember measuring tube, if I take the water in the measuring tube, as here, which is greater? The force of attraction between the water and the glass is greater. So what will happen? The liquid will rises towards to the glass. That is what we used to call it as a capillary action. Do you all understand, everybody? So the capillary rise, next tomorrow's class we'll discuss capillary action. So here the force between the liquid and the wall, that what glass is greater. That is why it will form lower meniscus. Lower meniscus. Okay, everybody? So you can notice it. This is outside I am drawing. This is actually the outside structure. So inside you can see that. So they will form like this. This is what it will. Understand, Rudresh? So that is outside. So now this is the angle which we used to call it as. What is the angle which we used to call? What is the angle we used to call it as? Contact angle. So which angle their liquid is contacting the glass? Now if I take here, cohesive forces are stronger than adhesive. So if I fill the mercury in the beaker, so all of you observe, the liquid will be the force of attraction. The liquid will be pulling down more than the surface glass. So the mercury will be rising like this, upper meniscus. So that is how you will be getting the curve like this. Okay, everybody. Now here the angle, if I draw perpendicular and if I see, so angle is what, everybody? Greater than 90 degrees. So that is why it is a concave or convex. Convex meniscus will form. Convex meniscus will form. And here what meniscus will form? Everybody. Concave meniscus will form. Okay, ma? Understand, ma? Everybody, girls. This is the convex meniscus. And this is what meniscus, Pradosh? It is the concave meniscus. So outside and inside both you see. So this is outside and this is inside. So inside is the convex meniscus. Okay, everyone? So that is what it is. So here adhesive forces are less stronger than cohesive forces. That is how it will be rising up. So I hope you all understand, everybody. So now if you have noticed it, so what will happen, everyone? So if I take that, so FMM, the mercury particle, the force of attraction between mercury is greater than force of attraction between mercury and glass. So you all notice it. So what will happen if I've been taken the mercury, everybody? The perpendicular force which is acting between the mercury and the glass is, that is what? FMG. Okay. And the force of attraction between the mercury and the mercury particles away from them, that is what? FMM. Then net force will act. Okay. Sorry. Net force will act between them. So that is what? 1 minute, everybody. So this is what the between. So this is the pressure which is exerting out from it. So then, as we know, everybody, so it is forming the depression, rise, it is moving depressed. So the net resultant force acting between them. So that is what? The F net. So F net will act between them. So F net is, if you say, everybody, always it is what will happen? Perpendicular to the net liquid surface. Liquid surface, it is always will be perpendicularly to that. That is what you have to remember. So if the liquids is having greater surface tension, they will form the upper meniscus, that is what? Convex. If they're having liquids having lesser surface tension, then they are having the lower meniscus. So now measurement also, class 8th book, if you're having, Prados already shared, you see, while you are measuring the water, you are not supposed to consider this is your measurement. For example, here it is showing 30 ml and here it is showing 28 ml. Then what is your correct measurement? 28 ml or 30 ml? What is that liquid? Everybody? Yes, please. 28 ml. Only this is the main correct exact. Then if it is a mercury, for example, here 28 ml, here 30 ml, then what is the correct measurement? 30 ml is the correct measurement. You have to take, this is the exact volume of the liquid. This is the exact volume of the liquid. So in that 8th class book, they will explain how to measure the liquids, upper meniscus, lower meniscus and all. Go through that and read. So this is what is about it. And rising like this or like this, whatever it is, if you have taken, okay. So whatever, that is what we used to say capillary action. And tomorrow, mostly we'll study this capillary action and we'll wind up. That is what is the last concept is present. I hope you all understand today's class. Anybody having any doubt, you ask me. I'll share the 2 questions. Morning, when you are free, try to wake up and spend at least 10 minutes. So in that, you will find one IIT question. Definitely, you are able to solve. But there is a concept, call it as a mole concept. Class 9th, you might be studied mole concept. I have taught you many people. So that mole concept they are going to use in that. So try to solve that and make it everything. Okay, solve it 10:40. Everybody can sleep and wake up morning. Thank you, everybody. We'll meet in tomorrow.